Hello class, today we're going to talk about the last section of Chapter 5, which is 5.6, Graph Inequalities with Two Variables. By the end of today's lesson, you will be able to graph the inequalities with two variables, as well as find the solutions to these inequalities with two variables. Some new vocab related to inequalities with two variables. First we have the boundary, and that is a line or curve that separates the coordinate plane into various regions. In our case, we are going to only be using lines. Half plane is one side of the boundary when you graph an inequality with two variables. That does not mean that the coordinate plane is directly cut in half. It just simply means that there is a left side and a right side of the line that you have graphed. When we have a closed half plane, that means the solution includes the boundary line. So any point on the line is part of our solution. In order to indicate this, when we graph, we're going to graph a solid line, so a straight line. This is similar to when we were graphing with one variable, that closed dot. The open half plane is the opposite, where it does not include the boundary line as part of the answer. So all of the points on the line are not part of our answer. This is going to be graphed with a dashed line and is similar to our open circle from one variable inequalities. I will say I want you to make sure that you are making very clear whether it is a solid line or a dashed line. If I have to guess on any homework that you turn in or on the test, I will just mark it wrong, so make sure it is very distinctly either a solid line or a dashed line. Steps for graphing. If necessary, solve for y. Like we talked about in that graphing review that you watched yesterday, you need to have it in y equals mx plus b form into graph. There won't be an equal sign anymore, but we still want the y mx b format. You're going to go ahead and graph that boundary line, again, using a solid line if we want the answer to be included. So that's if we have the or equal to part of our inequality. And then we're going to use a dashed line if it's just less than or greater than. Then, similar to what we did before with one variable, you're going to need to test a point to decide which side of the graph that you were going to shade. So before it was, are we going to draw the arrow to the left or the right on the number line? Now we need to decide which part of the graph is going to be shaded in as part of our answer. Before, we plugged in 0 for our variable. Now we are going to plug in 0 and 0 for both of our variables. So both for x and y will turn into 0. You're going to, again, determine if that is true or false. If it's true for 0, 0, you're going to shade the side with 0, 0. If it's not, so if it is false, you are going to shade the side without 0, 0. This will make more sense as we are going through and actually doing the problems, but this just gives you an idea of how we are going to go about graphing. So, looking at this first example, we already have y by itself, so we are going to start at that b value, which is -1, and then we're going to look in front of the x for our slope, so we're going to put in 1 over 1, so up 1 and over 1. Then we need to look at our inequality symbol. So we've got a greater than, there's no equal to part. So we are going to go ahead and draw a dashed line in for that. Again, making sure it is very clear that it is a dashed line and not a solid line, and then putting the arrows on the end. The next part that we have to worry about is deciding which side to shade. So as I said before, you're going to want to use 0, 0 as a test point because the line is not touching 0, 0. So that means we're going to plug in 0 for x and 0 for y, and then see if this is a true or false statement. So when I do 0 minus 1, I get -1 is greater than 0. That is false. So because it is a false statement, I'm going to go ahead and shade in on the side without 0, 0. So that means every single point on the right side of that line is a possible answer to this problem. So for example, if I pick an easy one and I pick 10, 1, so that's part of the answer. That means when I plug in 10 for x minus 1 is greater than 1 for y, I should get an answer that is true, and I get 9 is greater than 1, which is indeed a true statement. So you could pick out any point on that right side of the line, anywhere in that blue shaded area, and you would get all true statements. If you picked anything from the left side or that not shaded area, you would get all false statements. So go ahead and try this one on your own, graphing the line and then shading in the correct solution side. So when we graph, we start at up 5 and then we're going to go up 1 and to the right 1. It is a solid line because we have greater than or equal to. When we plug in 0, 0, we end up with 0 is greater than or equal to 5, which is a false statement. So we're going to shade on the left side of the line this time. If you have questions about that, let me know when you get to class. Sometimes the y is not isolated, so we are going to have to solve to get it into y equals mx plus b form first. My recommendation to you would be to make sure that the y is positive. So there's a couple different ways that you could solve this. The first thing you could do is subtracting 6 from both sides and say negative 2y is less than or equal to negative 6x plus 4, and then going ahead and dividing by negative 2 on all of the pieces. If you're dividing by a negative, you need to be careful that you flip that inequality symbol while you are solving. If you want to avoid doing that, the other way that you could have solved this was starting by adding 2y to both sides. So I now have 6x is less than 4 plus 2y. Then I'm going to go ahead and subtract the 4 from both sides. So I've got 6x minus 4 is less than 2y. I still have to, when I solve, divide everything by 2, less than or equal to. And we got 3x minus 2 is less than or equal to y. Same answer as we got before, just a different way of getting there. If you don't want to deal with the dividing by negatives, I would suggest adding the y first. So now when we come to our graph, we're starting at negative 2. We're going to go up 3 and over 1. Because we have the equal to part, we are going to go back to a solid line when we graph. And all the way through the entirety of the graph, putting our our arrows on the end to show that it is a line. When you go back to test your points, 0, 0, you should plug it into the original equation. In case you made a mistake somewhere in your solving, you don't want to double that mistake by plugging into an incorrect equation. So you want to make sure that you plug 0, 0 into the original equation. So I'm going to plug in and get 6 times 0 minus 2 times 0 is less than or equal to 4. 6 times 0 is 0. 2 times 0 is 0 is less than 4. 0 is indeed less than 4. So this is a true statement. So we are going to shade on the left side of the graph because that is the side that 0, 0 is on. Go ahead and solve this one on your own, getting y by itself, and then remembering to shade for your final answer. So you get an equation of y is greater than negative 4x plus 8, starting at 8, going down 4 and right 1, and graphing with a dashed line because there is no equal to part. Plugging zeros in for the original we've got 0 plus 0 is greater than 16. That is a false statement, so you are shading on the right side of that line. Sometimes similar to that graphing review that we did, there might only be one variable, but it still wants you to put it on the coordinate plane. So you're going to solve the equation for that variable. In this case, adding 3 to both sides, getting 4x is greater than 20, and then dividing by 4, giving me x is greater than or equal to 5. Again, you're going to come over and put that point at 5. Because it is greater than or equal to, we've got a solid line. And then we are still going to plug in 0 into the original equation. So 4 times 0 is 0, minus 3 is greater than or equal to 17. Negative 3 is not greater than or equal to 17, which means 0 cannot be part of our answer. So I am going to shade to the right. Go ahead and solve this one on your own. Subtracting 6 and dividing by 2, you get y is less than 3. So putting that dot at 3 and a horizontal dashed line going across because there's no equal to part. Plugging 0 into the original, you get 0 plus 6 is less than 12. 6 is indeed less than 12. So you should have the shading on your final answer being below that line. If you have questions about this or anything else from the lesson, please let me know when you get to class.